evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to my latest video. This one is going to be the Spot On Weather 2024-25 Winter Review. Nice little snowy scene here on the title slide. For all you snow lovers out there, you snow hounds, let's go ahead and get into this video. On the agenda of tonight's video, what we're going to do is we're going to look at the United States, the monthly temperature and precip anomalies from last winter, the 24-25 winter season. We're going to look at the national highlights, the teleconnections, what the pattern drivers look like for the those breakdowns. Then I'll take a look at the sea surface temperature anomalies discussion, the solar activity. I'll get into a discussion on that, the Hampton Roads, Virginia specific details for the winter season. And then we'll just do a quick winter 2024-25 winter season summary. So we'll start off nationally at the United States level. We'll talk about some of the major pattern drivers or teleconnections. Then we'll go into the sea surface temperature anomalies, the solar activity. We'll just throw that in there as well. And then we'll get more local with Hampton Roads, Virginia specific details of what happened during the 24-25 winter season. Starting off with a national look at the December 2024 mean temperature anomalies. Okay, let me get my laser pointer out here. Okay, so when you look at the December 2024 temperature anomalies, the blue coloring is below normal. This deeper brownish white color, the deeper hues of orange are well above normal temperatures, so much warmer than normal. So in December of 2024, you see where the warmest temperatures were, generally from western Montana down into Wyoming, parts of northeastern Colorado, as well as parts of Nevada. Even along the immediate west coast, temperatures were running 1 to 3 degrees Fahrenheit above normal for December of 2024. Temperatures were just slightly by a degree or two Fahrenheit above normal across Illinois, Indiana, and Michigan. Wasn't a major, above normal surplus in temperature there. Right along the east coast, though, from Georgia up into Vermont, New Hampshire, Massachusetts, light blue coloring here indicates slightly below normal temperatures. Not by much. We're talking only by about a degree or so, 1 degree Fahrenheit below normal along the immediate east coast for December. Looking at the December 2024 precipitation anomalies, the dark brown, well below normal, very dry conditions in the dark brown color. So you can see what's going on in December. Very dry in Southern California, Arizona, New Mexico, Southern Utah, into Southern Nevada, including you in Las Vegas, all the way over to the western portions of Texas and up into western Kansas and Nebraska, and eastern Colorado. Very below normal as far as precipitation anomalies. Slightly above normal in this lighter green across the Pacific Northwest in Washington State and Oregon. Also slightly above normal precip from northeast Texas, southeast Oklahoma, Arkansas, Missouri, specifically the southeastern part of Missouri, on up to Indiana, Ohio, and lower Michigan. Also notice from about Pennsylvania, New Jersey, Maryland southward, Virginia, the Carolinas, into South Georgia, and as well as into northern and central Florida, it was below normal as far as precipitation, average well below the normal precipitation for December of 2024. Now let's examine January of 2025, the mean temperature anomalies across the United States. I mean, just look at the difference here, right? December 2024, January 2025. The dark greens or lighter greens and these blues all indicate below normal temperatures. And we're not talking just slightly below normal for the mid-Atlantic and southeast and even along the Gulf Coast and into Kentucky, West Virginia, well below normal temperatures for Kansas, eastern Colorado, eastern New Mexico, western Texas. Look at how much swath of just the southern U.S. in general, as well as the mid-Atlantic, was running well below normal in temperatures. We're talking 5 to 7 to 8 degrees Fahrenheit from the mean. Now, the mean temperature anomalies, what you do is you add up each of the daily high and low temperatures. You get the mean for the day, and then you take whatever the value is, and you got to divide it by 30 to get the overall mean in general. So this is average temperature anomalies. This isn't just like hey, what's the difference from the average high temp or what's the difference between the average low? This is everything total up these numbers. And as you can see, it's well below normal for a large chunk of the United States. For January 2025 precip anomalies, look how dry the western U.S. was last year. Now, this is a complete turnaround from the previous 2 winters before this, where you had a lot more moisture. The winter weather in the trough, upper trough, was out over the west. So we're talking much below normal, very dry across California, very dry across Washington State, very dry across Arizona and Utah, much below normal precip anomalies. Even you in the Midwest didn't get a lot of snowfall, below normal in January of 2025 from Illinois on into southern Wisconsin, southern Minnesota, and Iowa. Even New England was pretty much in a snow drought, below normal from average in the snow department from Pennsylvania, New Jersey, northward to Maine. And then there was some below normal precipitation anomalies as well across southern Virginia and the Carolinas and into parts of Florida. Really, the only spots that ran above normal as far as precip was central Montana, central Wyoming, eastern Colorado, and eastern Kansas and northwestern Missouri. I mean, really, those were the wetter areas for the month of January 2025. Now, what about February 2025? Mean temperature anomalies. All right, so remaining above normal across Arizona, New Mexico, western Colorado, Utah, Nevada, and southern California. This was an above normal area in February of 2025. And then look how much colder things got in Montana. The mean temperature anomaly for the 28 days of February, well below normal. We're talking 12 to 15 degrees Fahrenheit below normal across much of Montana, central and eastern portions at least, and then below normal readings across eastern North Dakota, South Dakota, all of Nebraska, all of Kansas. And then we actually had slightly above normal readings. We're talking above normal readings from southern Alabama and southern Georgia down to Florida. We're talking 4 to 5 degrees Fahrenheit above normal from the mean anomalies in that location. So if we compare the 3 months, the meteorological winter months, here's December 2024. There is January, which is just, it was a crazy 3-week period of, oh wow, just a lot of cold air coming in. And then there's February. Things kind of warmed up across the deep south and the southeast. Here is the February 2025 precip anomalies. Now look at this little green swath across the mid-Atlantic. And I'll tell you, parts of Virginia, they really cashed in on a big snowstorm, and I'll rehash that for Hampton Roads towards the end of this video. But look at the dark green Kentucky into West Virginia and to Virginia itself. This was a big corridor for wintry weather in February, a huge corridor. And you notice it's dry up along coastal New England. Not much in the way. Near average precip to below average precip in New Jersey and eastern PA. Well below average across southern North Carolina into coastal South Carolina, southern Georgia, and northern Florida. And look at how dry things were in West Texas, New Mexico, and Arizona, well below normal. And then also below normal across the Midwest again, Missouri, Illinois, Indiana, South Dakota, lower Michigan, below normal. Above normal across the northwestern U.S. there, including the Pacific Northwest, parts of Montana and the western sections of Montana, Idaho, Washington State, Oregon, and Northern California, and Northern Nevada. This was a wetter zone here for February of 2025. Now, here are some of the national highlights from December 2024, just for you to take a look at. We had an atmospheric river, which brought heavy rainfall and winds to parts of the drought-stricken East Coast on December 11th. This was the first significant rain event across the Mid-Atlantic and Northeast since August. If you can recall last fall, it was extremely, extremely dry across the Mid-Atlantic and New England. It was just days on end of high pressure. Just to give you an idea, right here in southeastern Virginia, we ran almost 36, 37 straight days without any measurable precip. I mean, think about that. 36 to 37 consecutive days, no measurable precip. In general, here on the 31st of December, about 38% of the contiguous U.S. was in a drought still. That was down nearly 6% from the beginning of December, thankfully. We did see drought conditions intensifying or expanding in parts of the southwestern U.S., the northern Rockies, and even across much of Hawaii. The state of Hawaii was very dry. Some other highlights here. We had a lot of southeast winds there aloft, bringing a lot of significant rainfall to Kodiak, Alaska. Precip averaged 167% of normal for the month of December, and it was the second highest on record. Also along the U.S. West Coast, we saw a series of atmospheric river events from mid to late December, which impacted portions of the West Coast and brought heavy rain and mountain snows to the region. Again, those drought conditions across Hawaii, the Hawaii Islands, amplified during December. We had 21% increase in drought coverage across the islands in general. And then also we had, as usual in the winter, late November, early December, we had the significant snow, lake effect snow, which buried cities downwind of the Great Lakes. Some regions in this zone here in the lower Michigan area received up to 6 feet of snow. And then you have still some severe weather outbreaks in December from Texas to Alabama, which brought heavy rain, damaging winds, large hail, and tornadoes around the December 28th time period. So overall, in summation here at the bottom, for December 2024, the average U.S. temperature for December was 38.3 degrees Fahrenheit, which is 5.6 degrees Fahrenheit above average. So this was ranked as the fourth warmest December in the 130-year record. The U.S. precipitation average was 2.34 inches, which is right around the average, ranking in the middle third of the record. So there you have it. That was December 2024. Nationally, in January 2025, what happened? Well, Alaska was pretty warm. All-time high January temperature records were set on January 24th in Tanana with a temperature of 43 degrees Fahrenheit. And on January 26th in Tok, Alaska, it got up to 49 degrees Fahrenheit. It also was the wettest January on record for Alaska. Meanwhile, in Southern California, we saw wildfires break out because it was so tremendously dry. This included the Palisades and the Eaton fires, just terrible fires for Southern California. This consumed more than 49,000 acres, burned over 16,000 structures during January. Meanwhile, down in the Hawaiian Islands, we had a strong low pressure system on January 30th, which brought damaging winds, severe thunderstorms, and flash flooding. Winter storm warnings were issued for the higher elevations of Hawaii. All right, so additionally, on February 4th, about 42% was in drought. I don't know why that says February 4th up there, so I'll just skip over that. We'll cover this when we get to February. I don't know why that's on this. Additionally, for winter weather, now let's talk winter weather for January 2025. There was a notable snowstorm for January 4th to 7th, which brought blizzard conditions to the Central Plains and 6 to 12 inches of snow in a stretch from Kansas to Virginia, stranding drivers on interstates and causing airport delays. And then down here, this was the big story of January 25. An Arctic air mass brought record-breaking cold and snowfall along the northern Gulf Coast, and extended as far south as the Gulf Coast the week of January the 19th. There was a wide swath of 6 to 12 inches of snow, which fell across coastal regions of Texas, Louisiana, Mississippi, Alabama, and the Florida Panhandle. This is just something you just don't see. I mean, these records for snow go way back in time. And then Puerto Rico had an average temperature of 79.6 degrees Fahrenheit, which it was the fourth warmest January on record for San Juan. Overall, the average U.S. temperature for January 2025 was 29.2 degrees Fahrenheit, which is 0.9 degrees Fahrenheit below average, ranking in the coolest third of the 131-year record. This was the coldest January since 1988. The U.S. precipitation average for January was 1.39 inches, so fairly dry nationally. The sixth driest January on record nationally. It was 0.92 inches below average for the month. And then finally, the national highlights for February 2025, Alaska remained warm. It was the third warmest winter for Alaska, the least snowy winter on record for Anchorage. Across the Pacific Northwest, We had flood warnings, which accompanied a strong storm across Oregon and Washington from February 23rd to the 26th with record-breaking precip. There were avalanche warnings for the higher elevations due to high winds and heavy precip, along with those above freezing temperatures. Finally, in California, around the 12th and 13th of February, an atmospheric river brought significant rain and snow, increasing the snowpack across the northern and central Sierra Nevada. It was the second warmest and fifth driest winter on record for Hawaii. And we also had some chilly conditions, some colder air. One of the coldest air masses of the season descended into the central U.S. the week of February 17th. The departure values were more than 30 degrees below average from the northern Rockies to the southern plains. And then across this particular area, the Ohio Valley, we saw a strong low pressure system on February 15th and 16th, produced an array of impacts from Alabama to New York. Severe storms produced tornadoes, wind damage, flash flooding, and power outages, transitioning to a heavy snow and blizzard conditions as the storm moved into the northeast. At least 20 fatalities were reported from this event. And then down here, down in Puerto Rico, it was the warmest winter, tied with 2019-2020, and the third warmest February for San Juan. Up here at the top, by early March, about 44.4% of the contiguous U.S. was in drought, up about 2% from the beginning of February. The drought conditions expanded or intensified across the Pacific Northwest, portions of the Southwest, Midwest, Southern Plains, and Hawaii. And the drought did let up and was reduced in intensity across parts of the Tennessee Valley, the Mid-Atlantic, Northern Rockies, and parts of the West Coast. So in summary here at the bottom, the average U.S. temperature for February 2025 was 34.9 degrees Fahrenheit, which is 1 degree Fahrenheit above average, ranking in the middle third of the 131-year record. The U.S. precipitation average for February was 2.13 inches, which was average for the month. And the average winter U.S. temperature, by the way, was 34.1 degrees Fahrenheit, which was 1.9 degrees Fahrenheit above average, ranking in the warmest third of the record. And the winter precip total, December, January, and February, was 5.87 inches nationally and 0.92 inches below average, ranking in the driest third of the December to February record. So there's your national highlights. Now let's take a look at some of these pattern drivers of teleconnection. So, I can recall this last fall. NOAA comes out with the forecast, the El Nino forecast, or the ENSO, El Nino Southern Oscillation forecast, right? They come out in the fall and say it's going to be a La Nina winter, all right? But, it didn't dip into La Nina territory for very long. It did technically meet the criteria for a La Nina, but it was one of the weakest La Ninas you'll ever see. And not only that, but last fall, the atmosphere, the multivariate ENSO index, MEI, the atmosphere did not respond and didn't behave as if it was a La Nina. It responded more like it was basically an ENSO neutral winter, the atmosphere. The thing is yes, you can get those temperatures, those water temperatures, cooling or warming above or below average, right? You can get those temperature readings, the water temperatures in the eastern and central equatorial Pacific, either above, warmer, or below normal. But if the atmosphere does not respond accordingly, based on whether it's El Nino or La Nina, well, guess what? It becomes more of a wild card situation. So this was in December 2024. I just captured 3 of the Nino 3.4 area, the Oceanic Nino Index, and this is from Levi Cowan and TropicalTidbits.com. But the blue line from September extending to December 6th. On December 6th, here at the end of this graph on the left, the value was minus 0.92 degrees Celsius, according to this CDAS. And then over here in the upper right, this is December 13th, a week later. It's around minus 1 degree Celsius, the water temperature. 1 degree Celsius cooler than average in that Nino 3.4 region. And the bottom right here for 20 December, it dropped. It was definitely in the La Nina territory, but again, it wasn't long-lasting in the La Nina territory, and it wasn't the strongest case of a La Nina. So the big thing here we noticed was La Nina was forecast to be dominant teleconnection, but it never really strengthened throughout the winter. If we look at, I skipped over from December to February because unfortunately I was recovering from a medical procedure in January, so I was kind of off my feet. But in general, what you see here now, this is February 14th here on the left side. And notice how this blue line is starting to ascend or rise. And now we're sitting at a minus 0.83 degrees Celsius below normal water temperature reading around Valentine's Day. Over here in the upper right, we go out to February 24th, and this temperature now, the water temperature has warmed even more in the Nino 3.4 region to minus 0.6, so 6/10 of a degree below normal, not much. And then over here on the bottom right, by February 28th, we're now basically at minus 0.5, just half a degree Celsius below normal for the water temperatures in that Nino 3.4 region. So you can clearly see the warming trend of these lines here, these three graphs between the Valentine's Day, February 14th on the left, upper right, February 24th, and bottom right, February 28th. So ENSO neutral conditions to weak La Nina occurred in February, and this was a minus 0.6 degrees Celsius departure from normal for those water temperatures. Then it went back to ENSO neutral conditions. This was huge. This was huge for the winter of 24-25. The tropical northern hemisphere, the TNH pattern. I am showing you an example of what a negative EPO, what it looks like. And this was the dominant upper air pattern, specifically in the month of January. Now, things got going with this TNH pattern early. And what do I mean by early? I'm talking Thanksgiving weekend. I remember I was traveling out to Western Virginia. I get out of the vehicle at the hotel, and it was like, oh my gosh, this wind is so cold. And this was the beginning of this negative EPO pattern, okay, in conjunction with this TNH pattern. So if you look at this TNH pattern, this is a positive TNH on the left. And notice the blue coloring here that indicates below normal 500 millibar heights around Hudson Bay. 500 millibars is about 18,000 feet above mean sea level. So you had a dominant, like, upper low situated over Hudson Bay. You had this massive ridge with the positive TNH working its way up to the Northeast Pacific, up to Alaska, even further north than that, in the Beaufort Sea, into the Bering Sea. So this humongous ridge sets up. You got the dominant vortex or low pressure, upper low over Hudson Bay. And then you got, some milder conditions across Puerto Rico, which we just talked about Puerto Rico having one of the warmest winters. It's no wonder because they were in this orange color, the above normal heights area, okay? We had a reloading Hudson Bay vortex, which was dominant with the positive TNH. Again, this is positive TNH for the month of January, just an example from NOAA. But look at this negative EPO pattern. Look at the Alaskan ridge was dominant. There's your troughing with the Hudson Bay vortex. So that negative EPO was in effect and in play. We had a negative EPO, which featured a ridge over Alaska and the trough over eastern North America. And look at the temperature pattern here in the bottom right. Look at this. Well above normal across Alaska, a warm winter. We just talked about that, right? What did we say about the winter in Alaska? Third warmest winter for Alaska. The least snowy winter on record for Anchorage. And so this is what I'm talking about. Like, you really have to pay attention to the weather in Alaska during the winter season because if they're well above normal and warmer than normal, that means ridging is extending north into their area. And that's going to help. Basically, over the top of that ridge, Arctic air is going to come down over the top of the ridge and crash into the U.S., specifically east of the Rockies. So it's always important to pay attention to the temperature trends in Alaska in the winter for sure. So this is what we have, cold air, especially for three weeks in the heart of winter. If you wanted some cold temperatures and some winter-like weather, this was an ideal setup, honestly, the negative EPO. the Eastern Pacific Oscillation. Now, the TNH pattern, look at these examples, the positive TNH. I mean, look at this. Now I'm sharing 500 millibar height anomaly here on the left. This is just an example. This was that frigid Thanksgiving weekend. This was the beginning of the overall setup that was repeated on and off throughout the winter of 2024-25. Here's your vortex, your upper low, your closed low around the vicinity of southern Hudson Bay. This purple coloring indicating well below normal upper heights at 18,000 feet or 500 millibars. This purple shading extremely below normal heights. And look at this. This is a complete trough situation in the Midwest to the East Coast, including New England. And then look at above that. Look at this ridging in the upper, on this left-hand graphic. Look at the ridging, the brown coloring, closed upper high, situated over the Bering Sea. And then all these higher than normal heights, basically you had another ridge extending to the southwest of Greenland and into eastern Canada. So you had higher than normal heights and warmer than normal temperatures to the north. And this just set, oh my goodness, this just set up this huge conveyor belt of cold air. With this ridging and the negative EPO way up in way up into the Bering Sea and north of Alaska. Cold air came from Siberia in this method and it basically moved from the northwest and southeast. And what a drop it was. And again, this was Thanksgiving weekend. This was the Friday after Thanksgiving. This was frigid. And this was a positive TNH pattern to a T. Look at the temperature anomalies over here on the right. The green's well below normal. We're talking double digits below normal in degrees Fahrenheit. So this positive TNH pattern developed in late November, as I'm showing you here, and it also extended into the first few days of December. We did have some modifications of this pattern throughout the month of December, but then winter really struck with a vengeance as far as the cold went for about a 3-week period in January. But this was a common theme. Now, this was the Pacific Decadal Oscillation, and this goes back to January 1854 for the PDO measurements, all the way to March of 2025. Yeah, you're saying to yourself, well, geez, that's a pretty deeply negative Pacific Decadal Oscillation. Did I have an example of that to show you? No, I don't. But what happens with the Pacific Decadal Oscillation when it's this far negative? That means I have colder than normal water temperatures, generally over the northeastern Pacific, off the U.S. West Coast, and I had warmer than normal water temperatures out into the central North Pacific. That's what this would mean. I wish I would have put the graphic here to show you what a negative PDO looks like. But I mean, this was steeply negative. Even today, it's steeply negative. So the winter of 24-25, it featured this negative PDO. Here's the EPO effects, just to kind of show you what's going on. A positive EPO was the major. Let's go back here. No, it's the negative EPO, and I apologize for that. We just showed you an example of the negative EPO pattern. We have this huge Alaskan ridge, and so this should be a negative EPO. I got to change that typo, but it is a negative EPO, everybody. This was a major teleconnection impacting the weather across the U.S. So we had a very weak La Nina. The atmosphere didn't behave like a La Nina necessarily. And then it went to ENSO neutral by the February time period, right? Then we have this negative EPO, which was just overpowering everything. Since El Nino or La Nina really wasn't the dominant teleconnection, North American teleconnections took over. So this negative EPO occurred that set up abnormally high upper heights from the Alaska, from that ridging into the Bering Sea and in the Arctic Ocean, with below normal heights downstream east of the Rockies, just like this graphic shows. Notice this strong upper level high right here, Gulf of Alaska up into Alaska, this ridge of high pressure, warm air aloft over the Northeast Pacific and Alaska. And that's why they had such a mild winter across Alaska last year. Now, we did get a lot of cross-polar flow situations. See this purple arrow indicating cross-polar flow with a negative EPO? This cold air basically moved right over the top of this expansive ridge that was over up into Alaska and the Arctic, and then it just went straight from northwest to southeast and plunged into the U.S. All right, so with a negative EPO, keep in mind, We have higher atmospheric heights, pressures, and temperatures in the Northeast Pacific and Alaska than in the subtropical East Pacific. This favors warm weather in Alaska as a cold pattern for most of the lower 48. You get cross-polar flow to set up that can bring Siberian chill from the North Pole into Canada and the U.S. Downstream of the trough, low pressure and cold air aloft over the U.S. opens a door to polar air intrusions by large cold high pressure centers, which ridge builds over northwest Canada. So this is where you get that reloading pattern. You get that Hudson Bay vortex in this purple coloring here. And the counterclockwise flow around that vortex brings northwest winds on its backside from central Canada down into the eastern U.S. I will change this. This should be negative. Negative EPO. Here is the EPO. Again, just an example. Now, what was this? This is the same as I had. Again, this should be a negative EPO, not a positive. Brought this cross-polar flow. I already showed you these two graphics. But in general, the reloading cold pattern peaked in the month of January, right in the heart of winter. Now, as far as the Pacific North American pattern for the winter of 24-25, this is showing you the PNA index. In general, we had a mainly positive PNA with above normal heights across the western U.S. throughout the 24-25 winter season. So you notice how these blue vertical bars are above the zero line here? That indicates mainly positive. See this in February? A positive PNA. Look at this, from 1 December all the way over to about 1 March. You don't even see the PNA going negative at all. It does go neutral around late January as that 3-week cold period finally broke. But look at this. This is phenomenal. For the PNA, compared to the previous 2 winters, we had that PNA crashing negative on more than one occasion and pretty strongly negative with the trough in the western U.S. Not last winter, it was mainly positive PNA. As far as the Arctic Oscillation, let's just go back to, I'm going to look at this oval circle here on the right. If we went back to 1 December, we had a negative AO really between the 8th and the 15th of December. It briefly went positive, but it was weakly positive through about late December. And then that big chunk of negative AO came in after the new year into January for the first 2 weeks of January. Then we went back positive by the end of January. But then look at this dip. Look at this dip in the AO from about the 10th of February right on to about the 20th of February. See this negative dip? And it's pretty significant. In fact, it's the most significant negative AO of all the winter. And then we had a major snowstorm in the mid-Atlantic on the backside of the strongly negative AO. So the AO fluctuated with a lot of up and down periods. That's what I got here, down here. But in general, you really see a couple peak negative periods. The first couple weeks of January, strongly negative AO, and then an even stronger negative AO into February, which resulted in just a massive snowstorm for Hampton Roads. Just phenomenal. Here is the NAO, North Atlantic Oscillation. Let's look over here on the right. We'll go back to 1 December. So we had a little bit of a slightly positive NAO, then it dropped negative between about the 10th and 14th of December. Then it went back positive from the 15th of December down to about the 30th of December. This was that milder period that the eastern U.S. experienced mid to late December. And then, boom, it crashes negative, the NAO, indicating blocking across the North Atlantic from early January to about the 13th of January. We did see a couple snow events for the mid-Atlantic into January. That's really when things got going. And then we see it going positive again there early February and positive again into late February. As far as the Mount Julian Oscillation MJO for December of 2024, this was on the far left, the MJO ending December 20th. The middle is showing the MJO through the 27th of December, and the far right is through January 3rd of 2025. So if you look at the MJO, this green line, that's the average of all these yellow lines. The yellow lines represent the ensemble members, all the different model members of this ensemble suite. The green line is the average split between all of these possible solutions. So you see in late December, we're heading into MJO phase 5. And then by the 27th of December, We're still kind of lingering in 5, going towards the null phase, and then back out into phase 6. And then over here on the right, by the January 3rd, we're heading towards the colder MJO phases. We're going from December 20th in phase 6, dipping back into the null phase, and then back out into phase 7 on January 3rd. So MJO generally started the winter in the milder phases 5 and 6 in December. By February, look where the MJO is, the green line here, February 28th on the left. Look at where it is. It's in the colder phase 8 phase. This is February 28th over here, right? So it's on the colder side, phases 8, 1, and 2, the colder side of the MJO phase diagram. Over here on the right, this is the March 14th. I just want to throw in a March date here. You kind of see how it's strongly in the negative. The MJO is strongly, follow the green line, is in the strong phase 1 and then strongly into phase 2. So phases 1 and 2. So the MJO emerged into the colder phases for the eastern U.S. Into January and middle February. Let's take a look at our friend, the stratospheric polar vortex. Okay. This was a winter of repetitive stratospheric polar vortex stretching. This was from, let's see, this is the 9th of December. You kind of see these white lines here, these solid white lines on this diagram. We're looking at the 30 millibar level. We're looking at the heights, and then the coloring indicates height anomalies. So if it's a yellow color or this mustard green color, we are having, they're below normal heights, but they're not as significant. The blue colors indicate the most significantly below normal heights. So just pay attention to the shape of these solid white lines, these upper height lines at 30 millibars, and you see this like elongation of the polar vortex here. Notice all these white lines are kind of stretched out. That's indicative of a stretched stratospheric polar vortex. And this was just the beginning of many. In fact, there were 10 total polar vortex stretches in the whole entire winter of 24-25. And the significance of this, a stretching polar vortex generally tends to lead to the coldest temperatures in eastern portions of North America. So when the vortex stretches, it's an event called wave reflection, where you get the tropospheric energy reflects off the stratospheric layer. It goes up over Eurasia, it comes back down over North America, and voila, the stretching events, the reflection of the wave energy off of the stratosphere all resulted in a pretty cold winter for the eastern portions of the United States. This is what I'm talking about from the research by Dr. Judah Cohen. For a stretched polar vortex, which we saw 10 times, unbelievable. There was wave amplification over Eurasia with a strengthened Scandinavian Ural blocking and deep, which then resulted in deeper Eastern Asian troughing. Okay. You get this upward wave energy flux, and again, it stretches out the polar vortex in the stratosphere. The energy is reflected back downward towards the Earth's surface, over towards North America, and then that reconfigures your polar jet stream to where you get this hugely amplified upper level ridge or higher heights over Alaska into the Bering Sea and the Arctic Ocean area, and this deep trough east of the Rockies, this dominant polar vortex upper low, and there you go. Multiple cold air outbreaks come down between this upper level ridge and this vortex over Hudson Bay. So 24-25 winter season featured 10 stratospheric polar vortex stretching events. These stretching events generally lead to increased cold air outbreaks east of the Rocky Mountains. The cold air outbreaks led to deep south and mid-Atlantic snowstorms in January and late February. Every time this vortex would stretch, another wave of Arctic air would come down into the eastern U.S. The cold, dry air limited snow across New England, however. So you have very cold air associated with these very, very strong high-pressure systems. We're talking 1035 millibar and stronger that would skirt east across New England and keep things just cold and dry across the New England area. Meanwhile, the mid-Atlantic, deep south, and southeastern U.S., those were the sweet spot areas. You had the cold high to the northwest, bringing a lot of cold air down from New England, and then you had these storm systems, these southern storm systems kind of moving across and offshore off the mid-Atlantic. So you have overrunning moisture, you have the cold air in the low levels, and it's the perfect recipe for winter storm setups. It was more of a suppressed storm track season from the Gulf of America and southeastern U.S. Here are the sea surface temperature anomalies for December 2024. You see the blue coloring here across the equatorial, eastern and central Pacific associated with the La Nina. And you see this warm ring of water there across the northwestern Pacific and north central Pacific, northwest of Hawaii. And then you see below normal water temperatures from the Gulf of Alaska down off the Pacific Northwest. That's associated with that negative PDO pattern. You get the warmer temperatures, that warmer ring of water over the north central Pacific and the northwestern Pacific, and cooler than normal water running along the Canadian coast down off the Pacific coast of the United States. And then you had your La Nina going on. And by 20 December, it looks like these colors got a little deeper blue. It almost looks like the La Nina, the coldest temperature anomalies, those water temperatures, shifted closer to this more of a central Pacific-based La Nina. And temperatures did warm a little bit across the waters off the U.S. West Coast due to that more of that persistent ridging pattern. Now we look at the sea surface temperature anomalies in January. This was 6 January on the left. Again, notice where the coolest temperature anomalies are. Generally have shifted from the East Pacific, East Equatorial Pacific to the Central Equatorial Pacific. See that closer to the date line? These deeper blue colors indicating below the deepest or coldest water temperature anomalies. And then you had warmer water, generally northwest and north of Hawaii to just off the California coast. By the 8th of January, in the bottom right, it clearly looks like a central-based La Nina. It really does. You had warmer than normal water temperatures extending across just to the north of that again. Had some below normal water temperatures off Maine and New England at that time as well, 8 January. This is February 2025, a couple sample snapshots of the water temp anomalies. Again, I just see it. It looks more like a central Pacific-based La Nina by the 3rd of February, and then warmer than normal waters across the north central Pacific and northwest Pacific. Bottom right, we're showing the 28th February sea surface temperature anomalies. Again, remaining below normal waters across the central equatorial Pacific, above normal, above that. And it was pretty much water temperatures were running below normal off Baja and off the northwest coast of Mexico, actually. Here was a solar activity. It was an active solar cycle 25, which was going on during the 2024-25 winter. You can see here now, how do we determine whether it's active solar cycle or not? We look at the number of sunspot, how many sunspot numbers on the sun there are. You clearly see we were in a solar minimum in 2020. Look how this line almost goes to the 0 value for sunspot number. And then you see just the smooth monthly values, this purple color line just keeps climbing and climbing. The solar activity continued to increase to about, it looks to me like right at the turn of the new year, early 2025, it looks like the solar cycle was peaking then. And then this is the forecast, the line as it goes downward, the predicted values here into the future. So we're looking at the next solar minimum probably around 2030 or just after that. We are on the downturn now at this point, but it was a very active solar cycle during the winter itself. Now let's break this down now at the Hampton Roads, Virginia specific details for December 24. This is literally right here from the station, from the weather station. The December mean temperature finished at minus 0.1 so 1/10 of a degree Fahrenheit below normal. Not a whole lot, almost practically call it near average for Hampton Roads for December 2024 as far as temperatures. There was slightly below average precipitation as well. It wasn't a big amount. You can see that down here in the bottom, my handwritten note. The monthly December precip departure was only 15/100ths of an inch below normal. The month did start cold with daily high temps in the 40s from the 2nd to the 4th. And then the month ended up on a milder stretch of days with daily high temps into the upper 60s and lower 70s. So by the time we got back, again, it was a pretty cold start the first couple of days of December. Then there was some moderation. And then yeah, then it was kind of like a lot of ups and downs from the 20th of December, right on through, heck, the late part of December. 28th and 29th of December, the high was 71 degrees. Okay. And this was before things really got cold in January. Because here's January 2025. I got some handwritten notes here at the bottom. January 2025 was the coldest month of the winter. Make no mistake about it for Hampton Roads. We're talking 5.2 degrees Fahrenheit below normal from the mean. Coldest January in a decade across the area. Much colder air arrived around the 4th and remained in place for the next 3 weeks. There was light snow and sleet mix events, which occurred. Our first event occurred on the 5th and 6th of January during the evening, but there generally wasn't much in the way of accumulation across Hampton Roads. There was another snow event that took place just 4 to 5 days later on the 10th of January, but it really only produced about 1 inch of snow measured in Virginia Beach. And then the final snow event for January 2025 occurred on the 21st when 1.5 inches of snow accumulated in Virginia Beach. So the big story here, monthly snowfall for January 2025 for Virginia Beach ended up to be 2.5 inches. You see the breakdown over here on the left. 11 January, the morning of, we measured 1 inch, and 22 January in the morning, we measured 1.5 inches. But overall, the precipitation departure was over 1.5 inches below normal. And then look at this. February 2025. This was an interesting month. February finished just 0.2 of a degree Fahrenheit below average, and there were a lot of ups and downs in the temperature department through the 17th of February. The biggest winter event, just unbelievable storm, took place on the 19th. We had this major snowstorm hit Hampton Roads with snowfall totals from 10 to 12 inches across the area. The temperatures were well below normal from the 19th through the 22nd. Basically, the day of the snow on the 19th, ending on late on the 19th that night. And that cold lingered because you had the snowpack in place, deep snowpack. It took some time to melt it. So we had daily high temperatures only in the 30s and lower 40s, the 19th to the 22nd of February. Now, we had a surplus of monthly precip departure. We were over 3 inches above normal. But most importantly for February 2025, and believe me, I've been here for a little bit. I haven't seen this, but we talk about like the 1980 storm around here for February going into March 1st. We talk about some big doozies of Februarys with snow, and this was one of the first real big February snow months I saw. Total here in my location, 11 inches of snow was measured. And you just see the maximum and minimum temperatures and how they vary throughout the month. A lot of ups and downs in temperatures initially, and then just really plummeted. Let me see here. Let's go to, I'm just looking at some of these temperatures. Okay, so for an example, it was 70 degrees on the 16th of February. It was 70 for a high. And then it drops to 41 on the 17th and 45. 45 on the 18th, 34 degrees for a high on the 19th during the snow with a low of 24 degrees. And then on the 20th, the high was 31. 21st, the high was 39. It was only 44 for a high on the 22nd. So just an impressive month. So 19th February 2025, this was the whole synoptic setup. This is what I look for every winter. This is what you look for. I mean, we had a 1050 millibar Arctic high pressure, which was situated across the northern plains on the 18th of February. This Arctic air mass just spilled down in the front side of the Arctic high into Hampton Roads by early morning on the 19th. Then we had this phasing between the northern and southern stream shortwave. So we had a shortwave in the northern stream and a shortwave in the southern stream, the polar jet and the subtropical jet stream. This phasing occurred between these two shortwaves on the 19th with a deepening low pressure off the southeast coast during the evening, which resulted in heavier snow rates. We were talking 1 to 2 inches of snow per hour as that phasing started really, those two pieces of energy really started emerging. The snowflake size was quite large, allowing for effective accumulation on the surfaces. What really was more impressive was how dry the air mass was, right? How cold it was. And when you cool down the air mass, it has less ability to hold much moisture. So you get more moisture, more snow out of colder air. And so with temperatures around 23 to 24 degrees Fahrenheit, with snow coming down, your snow to liquid ratios was 15 inches of snow is equivalent to 1 inch of liquid rain or liquid water. It, now, I will say, we really avoided it. We really dodged a bullet in Hampton Roads. Despite getting 10 to 12 inches across the area, there was a third piece of this upper level energy that was sitting back over the Appalachians. Had that moved quicker to the east and merged with these other two pieces of energy, we would have probably had snow accumulations exceeding 18 inches in Hampton Roads. No kidding. It was so close to a complete bomb cyclone right off the southeast coast. These were some of the totals from the National Weather Service Wakefield office. You see the orange colors for southeast Virginia. 11.2 inches, you got 10.5 inches in the area, 10 inches, and even across parts of northeastern North Carolina, you got hammered too. I mean, 12 to 13 inches near the Outer Banks. Now, one of the biggest things I always talk about every winter is when the coastal sections of North Carolina and Virginia get hammered with heavy snow, back towards Richmond, they don't get as much. And it's just a fact because the drier, colder air is moving in to the central and western part of Virginia with this low pressure offshore and that strong Arctic high in the northwest. You're funneling a lot of cold, dry air into this part of Virginia, the central and western portions, and you're just getting hammered on the southeast coast. So this was an impressive snowstorm for sure. On the 19th of February 2025. This was the surface map over here on the right, showing the area of low pressure off the South Carolina coast. I mean, look at this, 1048 millibar highs from North Dakota down to Nebraska. You're just funneling cold, dry air on the backside of this developing storm, and it's just a perfect situation to get a good snowstorm across Hampton Roads. This was the skew-T diagram during the storm. The red line indicates your air temperature, the green line, the dew point temperature. Whenever they're on top of each other, you have 100% relative humidity. You're completely saturated. You've got thick low clouds. You've got a lot of precipitation involved. You see some of the wind barbs here as we go up in height. So you got southerly winds and southwesterly winds affecting moisture over the top of the shallow, colder air mass at the surface. You did get a little bit of a temperature inversion, basically between 950 and 900 millibars. But you notice one thing here. This dashed line here, I'm running this cursor along, this diagonal dashed line, this is your freezing line here. So even though you had an inversion, those temperatures only warmed to the freezing point at about 850 to 900 millibars. And then it got colder than freezing again above that. So this was an excellent snow sounding for Virginia Beach, I'll tell you that. We're affecting moisture over a shallow, cold Arctic air mass. You had a lot of energy in the upper levels too. Look at these wind barbs from 300 millibars higher up in the atmosphere. Above that, you're talking 150 knot winds. So you're getting a jet streak involved in this process too, which is just you're in the perfect quadrant of the jet streak to really enhance the vertical rising air motion. Just unbelievable. It really was an amazing setup. Over here on the right, I talk about mesoscale banding a lot in the wintertime, and this is exactly what happened across southeast Virginia and northeast North Carolina. See these yellows and these, some of the yellow was some sleet pellets mixing in with the snow, which results in this bright banding effect. But in general, these darker greens indicate the heavier rates of snowfall. Okay, these are heavier rates of snowfall, higher decibel levels, and what happened is you end up getting this enhanced mesoscale convective banding effect. And it is prolific for producing huge snow amounts over short distances across southeast Virginia. It really, really is. This was my temperature sensor for my station here in Hampton Roads. Look at this. We had an outside air temperature of 27 degrees at this time, dew point of 21 degrees Fahrenheit, Your pressures were still fairly high at 30.34 inches, but this temperature and dew point combo is just phenomenal. And we're already at 78% relative humidity at this point. This was at 12:53, just before 1 p.m. on the 19th of February, right when the snow was just starting to fall, just after noon. Over here on the middle diagram, we're showing the 3:30 p.m. radar. The blue colors indicating the heavier snow rates. Over here on the far right at 7:15, we have even heavier snow rates in the green color, moving in towards from northeast North Carolina towards southeast Virginia. So this was the sweet spot of the storm. Just continuous snow moving from southwest to northeast. Just perfect setup. These were some of the pictures that I took on the evening of 19 February 2025. Look at down the street here. Just some glistening snow. It looks like diamond dust here. Just beautiful. It's still snowing heavy at this time. You can see some of the snowflakes in the streetlights. Over here in the middle, it's still coming down at this point in time. Look at that winter looking sky, that snow sky, I like to call it. I grew up in the Midwest, and I love seeing the snow sky in the winter because I'm a snow lover, but it's just a very thick stratus, reduced visibility in the distance. Look at the snow piling up on vehicles and the bushes out here. This was the next morning on the 20th of February 2025, nearly 11 inches of snow at this point. And it had stopped snowing. The snow just got heavier and heavier with the mesoscale banding effect. It really got going after sunset. All right, so here is the 24-25 winter season summary. We had a weak La Nina, and yes, it was a negative Eastern Pacific Oscillation EPO, which dominated the pattern. From time to time, we had that positive tropical Northern Hemisphere pattern as well. Those were the main teleconnections that drove the winter. The La Nina was so weak that I really believe it didn't really do much as far as alter the atmospheric pattern from the Pacific to the U.S. I think the major teleconnections of last winter, the 24-25 winter season, was this negative EPO along with that positive TNH. They were game changers. Yeah, we did have those periods of negative Arctic oscillation, which generally means colder temps in the eastern U.S., but really, 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 these two constructively interfere with each other, the negative EPO and positive TNH, and it was just a very interesting winter. So the negative EPO with the cross-polar flow started in late November into early December, and this just became the recurring theme of the winter season. This positive TNH, negative EPO enhanced the strength of this Hudson Bay vortex, allowing for a reloading pattern of cold Arctic air into the eastern U.S. and mid-Atlantic. Specifically in the month of January, we had well below normal temperatures for an extended time. We're talking 3 weeks during the heart of winter. I can't recall a winter where, for Southeast Virginia in general, I'm speaking, yeah, you get cold for maybe 48 hours, but after 48 hours, it warms up again, it moderates. And that just didn't happen in January 25. It was solidly below normal for weeks. The upper air pattern was just locked in with that ridging off the west coast of the U.S. up to Alaska. It was dry with above normal temps across the western U.S. with those abnormally high upper heights in the ridging from Alaska northward to the Bering Sea and Arctic Ocean. The storm track was suppressed to the south across the mid-Atlantic and southeast. From the Gulf Coast storm of January to the major storm here in the mid-Atlantic in late February, it was just unbelievable. Arctic high pressure and dry air kept snowfall totals below normal across New England. And then along with that negative EPO, we had stratospheric polar vortex stretching events. 10 times of the stretching events during the winter season. So during these stretching episodes, you get cold Arctic air, which readily descended into the eastern U.S., resulting in below normal temps. Then that vortex would contract and kind of go back, more symmetrical shape back to the North Pole, and then it would it would stretch out again, and next shot of cold Arctic air would come in. It was just a reloading cold pattern. And there it is. I kind of explain it. When the stratospheric polar vortex returned to its original position over the North Pole, we briefly had milder temperatures that set in, but it was very short-lived. Unlike past winters where the cold is usually short-lived and then you get moderation. The PNA pattern was positive for most of the winter, with many in California wondering when it would rain. So it was a major drought situation in the southwestern U.S. Occasionally, the North Atlantic Oscillation, the NAO, would turn negative in combination with significant upper level ridging or blocking across western North America. Would occasionally form that ridge bridge where you get the upper level ridging from the Atlantic side in eastern Canada, merging with the upper level ridging on from the Gulf of Alaska, Northeast Pacific side, and merging over the top. I call that the ridge bridge. And below that ridge bridge, those anomalously high heights across Canada and the Arctic, you get below normal heights across the mid latitudes. You get a storm track further south. So overall, it was a winter to remember for Hampton Roads, Virginia cities. A lot of cold temperatures and snow. All three meteorological winter months for Hampton Roads actually finished below normal as far as the mean temperature goes. Here's a breakdown. This was January temperature or departures rather. In the month of January 2025, there were 21 days below average with below average high temps. 21 days were below average. For the high temps, we had 1 day at average, and we only had 9 days with above average high temps in January across Hampton Roads. So there you have it. We had 24 days which featured below average low temps, only 2 days which had average low temps, and we only had 5 days with above average low temps. I mean, the ratio of below average to above average in the month of January 2025 for Hampton Roads was astounding. Winter precip events, they started up on the 5th and 6th of January with a mix of snow and sleet with no accumulations. The next winter event then moved in on the evening of Friday, the 10th of January 2025, with the first accumulating snow of the season, about 1.5 inches. Another winter event took place on the 20th of January with light snowfall accumulations around 1 inch. I will say my experience in Hampton Roads and what I've observed, when early January is colder than normal, so we get Arctic air in here, and then we get snow in early January, at some point in time, that is like a prelude to some sort of accumulating snowstorm. I've seen Januaries in Southeast Virginia where it's just super mild, and the winter is a complete dud for snow. So just my observation. The biggest snow event for the winter for Hampton Roads took place on 19 February 2025 when there was Arctic air in place in combination with deepening low pressure off the Carolina coast, which produced nearly 1 foot of snow across the area. All right, that wraps things up. Wow, that was a mouthful, wasn't it? My goodness. But I think it's really important to capture what happens in these winter seasons. So I like to do these winter summaries, and I look at things not only from my local Hampton Roads level, but I also look at things from more the global levels as well as the national levels, right? Like what was going on. I would say the winter of 24-25, the positive TNH, the negative EPO, the persistently positive PNA as well, occasional bouts of negative AO, but most importantly, the 10 stretching stratospheric polar events. All of this in combination, plus we just had a almost non-existent La Nina. Let's face it. Wasn't doing much to the pattern. We turned to ENSO neutral conditions by mid to late February. So bottom line here is, you look at all these teleconnections, these pattern and climate drivers, and there you have it. So hope you like this. I like to record this stuff. It's always a running history. You can look at this video anytime and say, man, what was winter 24-25 like? And you can go back on my YouTube channel and look at that and just kind of see what happened. All right, that's all I got for now, everybody. And that is it. Until next time, take care and God bless everyone.